Imagine you're on a peaceful beach, watching the waves lap against the shore. The sun is setting, casting a golden glow on the horizon, when suddenly, the water begins to pull back. At first, it seems harmless. But then, you notice it's pulling back much farther than usual, revealing parts of the ocean floor that rarely see sunlight. This strange phenomenon signals a powerful force stirring deep beneath the waves, a tsunami. In this video, we'll take you on an epic underwater journey to uncover how tsunamis form, the incredible forces behind them, and what makes these waves so unique and dangerous. So, grab your scuba gear as we dive into the science of tsunamis. Our story begins far from the shore, deep beneath the ocean's surface, where colossal tectonic plates are constantly shifting. Imagine these plates as enormous puzzle pieces that make up Earth's outer layer, floating atop molten rock. Most of the time, these plates move slowly, creating small, barely noticeable changes. But occasionally, they collide or scrape against each other, causing sudden, violent movements, earthquakes. When an underwater earthquake strikes, especially in subduction zones, areas where one plate is forced beneath another, it can displace a vast volume of water. Think of it like dropping a stone into a still pond. The energy from that stone ripples outward, creating waves. In the ocean, however, this energy release is massive, enough to lift billions of tons of water. This is the birth of a tsunami, a massive surge of energy spreading through the water at incredible speeds. At first, this energy travels as a series of waves across the open ocean. But these waves are unlike any you've seen at the beach. Out here, they're spread out and hardly noticeable, maybe just a few feet tall, blending in with regular waves. However, while ordinary waves are driven by wind, tsunamis carry the raw power of the Earth's movement. This energy propels the wave through the water at speeds of up to 500 miles per hour, comparable to a jet plane. The vast open ocean hides the true size of a tsunami. Since the ocean is so deep, the wave's energy is distributed from the surface to the seabed, making it almost invisible. But don't be fooled, though it seems small, it carries a huge amount of energy, traveling silently toward distant coastlines. As the tsunami approaches shallow waters near the coast, its appearance changes drastically. The ocean floor rises, pushing the wave upward. The energy that was once spread over the deep ocean now has nowhere to go but up, making the wave grow taller, sometimes to heights exceeding 100 feet. Now, we're back at the beach, where you first noticed the water pulling back. This phenomenon, known as the drawback effect, is a dangerous warning sign. It happens because the first part of the wave trough, or low point, reaches shore first, pulling water away before the crest, or peak, crashes in. When that towering wave finally reaches the beach, it's not a single wave anymore. It arrives in a series of surges, each packing destructive force. Unlike regular waves that roll in and recede quickly, tsunami waves are more like a powerful, continuous flood, sometimes lasting several minutes. As wave after wave crashes ashore, it can push miles inland, sweeping away everything in its path. While underwater earthquakes are the most common cause of tsunamis, other natural events can also trigger these massive waves. Volcanic eruptions, for instance, can produce tsunamis if enough energy is released. In 1883, the eruption of Krakatoa created waves that reached 130 feet, devastating nearby islands. Underwater landslides can also displace huge amounts of water. Imagine a hillside suddenly collapsing into the ocean. The weight of that landslide pushes water out of the way, creating waves that can develop into tsunamis. These alternative sources, while less common than earthquakes, are powerful reminders of how various geological forces contribute to the creation of these waves. With the devastation that tsunamis can bring, scientists around the world are working to predict and warn people before these waves strike. Tsunami warning systems rely on a network of seismographs and buoys. Seismographs detect underwater earthquakes and alert scientists to potential tsunamis. Special buoys floating in the ocean measure wave activity. If unusual wave behavior is detected, a warning is sent out, giving coastal communities precious time to evacuate. In some regions, these warning systems have helped save countless lives. But tsunamis travel fast, and not all areas have advanced detection technology. This is why coastal communities, especially in earthquake-prone regions, have evacuation plans and drills to prepare for the possibility of a tsunami. Our journey has taken us from the ocean floor to the shoreline, uncovering how tsunamis form and why they are so powerful. These waves may begin as subtle movements beneath the ocean, but they grow into unstoppable forces of nature, challenging us to learn, prepare, and adapt. By understanding the science behind tsunamis, we gain respect for Earth's power, while scientists and communities work together to protect lives and property from these colossal waves. So next time you're near the ocean and notice the water pulling back, remember this story, and know that deep beneath the waves, forces beyond our control are constantly at work, shaping the world we live in.